Triangle or circle is placed in each of the 9 squares of a 3x3 grid. Shown below is a sample configuration with 3 triangles in a line. How many configurations will have 3 triangles in a line and 3 circles in a line? Okay, so what we really have here is we sort of have a tic-tac-toe, except we don't stop after one side gets 3 in a row. So we want to calculate how many configurations will have 3 triangles in a line and 3 circles in a line. And what you have to realize is that you could potentially have a configuration like the one I'm about to draw, where there are actually 2 rows of triangles that are 3 in a row and 1 row of circles. This is a perfectly valid configuration. Even though you have two 3 in a rows for triangles, this still satisfies the requirements. There's at least 1 3 in a row of triangles and 1 3 in a row of circles. So we need to be able to take this kind of thing into account. What happens if you have 2 3 in a rows of one kind as opposed to just 1? So what we are going to do is we are going to split this problem into 2 cases. Case 1 will be there are two 3 in a rows of one kind and one of the other. There are 2 3 in rows of one kind. And remember, it doesn't just have to be triangles. For example, if you have this middle row be circles, then you'd have 2 3 in rows of circles. And case 2 is not case 1. Case 2 is sort of like this example we are given, where there is actually this example doesn't even satisfy the requirements. But if this were an O, then this grid over here would satisfy case 2, because there'd be 3 in a row of triangles, 3 in a row of circles. But there isn't like two sets of 3 in a rows for triangles, or 2 sets of 3 in a rows for circles. Okay, so let's start out by trying to count case 1. There will be 2 3 in a rows of one kind, and what you have to realize is a few things. First of all, these are going to make the problem a lot easier. First of all, there is absolutely no way whatsoever that anything will be diagonally, because if I have like a diagonal of 3 O's, then how am I going to ever get 3 triangles in a row? That's impossible. Like this row already has a circle, this row already has a circle, that row already has a circle, and these 3 columns each already have a circle in them. So like it's impossible to get a 3 in a row for triangles. So no way for diagonals, which means that everything has to be either vertical or horizontal. Second thing to notice is that if I have a horizontal 3 in a row, there is no way I will ever be able to get a vertical. So like if I have 3 O's in a row like this, the only way I will ever be able to get a 3 in a row for triangles is if they're horizontal, like this one or that one, because like any column already has an O in it. So can't make 3 triangles if you already have an O. So if it's horizontal, then everything must be horizontal. And if there's a 3 in a row that's vertical, then everything must be vertical. So what we do here is, just for this case 1, there are really 2 ways to make this happen. One of them is for all 3 of them to be vertical, and one of them is for all 3 to be horizontal. And you can actually, since both of those cases are symmetric, just multiply one of them by 2. So like if I find the number of ways that you could have horizontal, 3 in a row horizontal like this, if I count the number of ways for something like this to happen, I can just multiply that by 2 to account for like if all 3 in a rows are like vertical or something, because both cases are essentially the same thing, except you're just looking at it differently, like from a different angle. So how many ways are there to put 3 in a row Just all three in a rows are horizontal. Well, the thing is, you either have 2 3 in a rows of a triangle or 2 3 in a rows of a circle. So you can multiply that by 2 as well, because without loss of generality, let's assume that two of the triplets are circles and one of them is a triangle, and then you can kind of mirror that for two rows that are triangles and one row that's a circle, because it's all symmetric anyway. So I'm just going to multiply this case by 2. And how many ways are there to rearrange one of these so that the grid is not identical? Like, for example, you could have the circles in the first row and the circles in the second row and the triangles in the third row, or you could have a triangle in the second row, or the triangle could be in the first row as well. There are 3 ways, because there are 3 ways to place the triangles in a row, and no matter what you do, the circles must go in the other 2 rows. So 2 times 3 and then times 2, because it could be either vertical or horizontal. So case 1 yields 12 possible configurations. Now, case 2 is anything that is not case 1. And what case 2 really is you're saying, okay, what happens if I have 1 3 in a row for triangles, 1 3 in a row for circles, but no other 3 in a rows? That's a key. You don't have any other 3 in a rows besides the 1 for circles and 1 for triangles. Now, the same things hold. You can't ever have a diagonal. You can't have both a vertical and a horizontal at the same time. So both the triangles and the circles that are 3 in a rows must either be both horizontal or both vertical. And the cases are once again symmetric, because if you turn your head 90 degrees, everything that's vertical becomes horizontal and vice versa. So you can just multiply that by 2 as well. And without loss of generality, we'll assume that both 3 in a rows are horizontal, left to right. Now, since there is exactly 1 3 in a row for triangles, how many ways are there to choose a row that has those triangles? Well, there are 3 rows, and the triangles could really be in any row. So 3 ways. So let's say I place the triangles in this row just for example's sake. Now I need to make a row that has 3 circles in a row. And how many ways are there to choose the row that has those 3 circles? There are 2 remaining rows. But what about this last row? It can't have 3 triangles in a row, and it can't have 3 circles in a row. But what it can have is some mixture of triangles and circles. So how many ways are there to fill up that last row with triangles and circles? Well, let's just consider each box individually. So how many? So this first box over here can either be a circle or a triangle. This box over here can either be a circle or a triangle. This box over here can either be a circle or a triangle. So what does that mean? There are 2 ways to choose what's in here, 2 ways to choose what's in here, 2 ways to choose what's in here. But you have to be careful, because if all 3 of these are circles or all 3 of these are triangles, then you've violated case 2. So what you're going to do is you're going to need to overcount and then subtract a few things. So disregarding the restrictions, there are 2 ways to choose the first box, 2 ways to choose the second box, and 2 ways to choose the third box, for a total of 8. But you can't have circle, 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 or triangle, triangle, triangle. So those are two configurations you cannot have. So 8, you'd have to subtract 2 from this 8 to get a total of 6 ways to fill up this last row. So you multiply that by 2, 3, and 2. So case 2 yields 2 times 3 times 2 times 6, which is 72 possible configurations. So your final answer is going to be 12 plus 72, which is equal to 84. So your answer is D. Thanks for watching, and I will see you next time.